So hi everyone, good evening. Hope my screen is visible to you and I'm audible okay. Can somebody please confirm?
Yeah,
Okay, good. Thank you. So welcome to Takshla VLSI. Myself Hari. I have a close to 13 plus years of experience in analog mixed signal layout design. So today I'll be the instructor for this analog layout design demo. So this should be an interactive session. So please feel free to interrupt me if you have any questions, doubt during the presentation. Okay, I'm happy to answer all of your questions. Okay, so with that, we'll start with the today's session. So just a brief introduction about Takshla VLSI. So we are one of the best VLSI institute offering all the VLSI courses for freshers, working professionals in all the courses within VLSI with 100% placement assistance guaranteed till you get the placement. And we have our physical presence both Bangalore and Hyderabad. So based on your personal availability, you can choose either Bangalore or Hyderabad. Okay, and even we offer online courses as well. I'm going to talk in my upcoming slides about that. Okay, so as a part of this course, we offer industry standard tools only. So Cadence Virtuoso is the industry standard tool for analog layout design. And once you successfully enroll for the course, you will get 24/7 tool support. Okay, literally you can access your tool anytime. Okay, so if you have some free time, you can just sit in front of your laptop or desktop and you can connect to the server and access your tools anytime. We have a very good experienced faculty and trainers with minimum of 15 plus years of experience in semiconductor domain, and majorly they are from reputed MNC companies. We have a collaboration with around 200 plus hiring companies, which includes most of the MNC companies who have a presence in India, some service-based companies and few startups as well. So once you successfully complete your course, there are very, very high chances that you are going to get a placement in one of those companies. We have a proven track record of placements. I'm going to cover that in my upcoming slides. And last but not the least, scholarship facility. So we offer scholarship facility to the eligible students based on their academic track record and all. So please check with the HR people related to the scholarship facility. So if you are eligible, you will get some fee discount. Okay, so based on your academics, right? So they will check whether you are eligible or not. So if you're eligible, you will get some fee discount. So why you should select Takshla VLSI? So what are the unique features, okay, you should consider, okay? So four major points or four major features I wanted to focus today. One is 100% placement assistance is guaranteed, okay? Everybody's primary goal to join in any of the course or any of the institute, right? To get the right placement with a decent package. So from our side, we are promising 100% placement assistance till you get the placement. Second point, 24/7 tool support. So once you successfully enroll for the course, right from the day one itself, you can access your tool. Okay, so that is dedicatedly given to you and you need not to share your tool credentials with anybody else. Okay, so the access will be dedicatedly given to you. You can literally connect and practice or complete your assignments anytime and from anywhere in this world. You just need to have a laptop or desktop with a decent speed internet connection. So literally you can connect from anywhere in this world, okay, without any lag or any issues in the tool. Course fee is very low, what we are quoting. And on top of it, there is a scholarship facility also available for the eligible students based on their academic track record. Satish, any question you have? I see you are unmuted. Okay, so if you have a question, you can feel free to unmute yourself and ask questions. If you are not able to unmute, you can type your questions in chat as well. I'll read those questions and I'll provide you the answers. Okay, so let's go back to the presentation. So last point, course syllabus. This is purely industry standard syllabus, what we are offering as a part of this course. Okay, we continuously monitor the latest trends in the industry. We update ourselves and we update our syllabus accordingly to meet the industry's requirements. Okay, so definitely whatever you are going to learn as a part of this course, this will make you a complete analog layout designer. Okay, so all the topics, whatever it is required for analog layout design, right? So everything is part of this. So I can clearly say and confidently say this is purely industry standard syllabus what we are offering as a part of this course. So I will quickly present the Takshla's corporate video. Give me a minute. I just need to share a different screen. Okay, let's go back to the presentation. So one thing you can observe from the video as well as from this slide. So we generally offer limited number of seats per batch, maximum 20 to 25 people per batch. And this number will be same for both online and offline batches. Okay. So the reason being, if somebody are lagging in any specific topics or if they missed any classes, right? So definitely instructor can have some time and he or she can sit with them and give them the additional assistance. Okay. So to provide that opportunity, we intentionally restrict ourselves to maximum 20 to 25 people per batch, and this number will be same for both online and offline batches. And another thing, we have our physical presence both in Bangalore and Hyderabad, and in both places we have very well maintained classroom and lab facilities available. So if you are in or around Bangalore or Hyderabad, so please visit our institute. Okay, I'm going to provide you the address at the last slide. You can take the screenshot during that time. So if you are interested, you can visit and you can experience the facilities. So here is the course information, and I recommend you to take the screenshot of this slide. So this will be helpful for your future reference. So if you need a complete course related information, please visit our website takshalavlsa.com/course/nlog layout design. And mode of study for this batch, we offer both online and offline classes. In both of them, we have a daily and weekend batches. Okay, so based on your personal availability and personal priority, you can choose either of it. Uh, by the way, the syllabus, everything will be same for online and offline. Okay, so there is no difference except your physical presence. Okay, so both online and offline, everything will be same. And in both the places, we have interactive classroom trainings. If you are planning to join in a daily batch, so you will have a classes Monday to Friday, Saturday and Sunday it will be off for you. So it will be 1 to 1.5 hour training class will be there based on the topic, and after that there will be a lab session followed by a lab session will be there, and you will get an assignment almost every day after the course, after the class, and you need to complete that assignment before coming to the next class. And if you're planning for a weekend batch, so you will have classes both Saturday and Sunday. It will be 3 hours per day, Saturday 3 hours and Sunday 3 hours. During the weekdays it will be off for you. Duration for this course is 4 months, and the main tool which we are going to focus here is Cadence Virtuoso. So if you know somebody who are already in the industry, especially in analog layout, right, you can just cross check with them. Cadence Virtuoso is an industry standard tool for analog layout design. Okay, close to 90 to 95% of the companies, they use the same tool. So whatever you are going to learn over here, okay, you are going to apply the same thing once you join in the any of the company. VPN access. So if you don't know what is VPN and all, don't get confused. Okay, so it is just your lab access. So once you successfully enroll for the course, you will get your lab access 24/7. Okay, and you can connect literally from anywhere in this world. We have few international students also who are connecting from US, UK, Australia, and Canada as well. So even they are also not facing any latency or lag issues. So literally, I can say you can connect from anywhere in this world. When it comes to the course materials, mostly we'll provide soft copies only, but if any hard copy has to given to you, right, we will collect your address and we will send through courier. You need not to travel to the institute for the materials. But this option is only for the people who enrolled for online classes. Generally for offline, right? So you will come to the institute, right? You can collect your materials directly from there itself. And if you have any queries, concerns, feedbacks, you can always write to info@takshalavlsa.com, or you can dial to the number provided below. Or alternatively, you can contact the HR person who sent you this meeting invite today. You can also contact them as well. Okay, so they will assist you if you have any queries and all. So any questions so far, whatever we covered till now? Any questions? Is it clear at least what we discussed till now? Okay, hope it is clear. This should be an interactive session, so I expect some answers from you guys. So if you are not able to unmute, you can type yes sir, no sir, something like that in chat as well. Okay, I'll be happy. At least I'm sure that you are paying some attention to my session. Okay, good. So what is the eligibility for this course? Okay, basic electrical and electronics background is required. Your educational qualification not really matters. And even if you are a working professional working in a different domain, like some software or embedded, and now if you are planning to switch your career to VLSI, you're also absolutely eligible, right from diploma, BE, BTech, MTech, and even we have few students who are pursuing their PhD as well. So your educational qualification not really matter, but only thing is you should have some knowledge on basic electrical and electronics things. Okay, what is semiconductor, what is PN junction diode, what is MOSFET, what is BJT, what is resistor, capacitor, inductor, all the basics, network analysis related. So some basics definitely required. Okay, so without that it will be difficult to understand the concepts what we are going to discuss over here. Uh, Salary scope. Okay, so let's say I completed my course and I joined in some XYZ company, expect as a salary or a compensation. As a fresher, from our side, we are promising 4 to 6 lakh per annum as a fresher package. Okay, but if you are really talented and if you are able to prove yourself during the course and during the selection process, there are companies which are ready to offer you much higher packages. We have a multiple practical examples also for that. Few of them I'm going to cover in my upcoming slides. But yeah, my sincere suggestion is focus on the course from the day one. Okay, complete the assignments on time and try learn whatever your instructor or mentor discussed in your classroom, and complete your assignments on time and read all the topics, whatever theoretical topics are there very well. So definitely there are very high chances that you will get a decent job with a right amount of package. Okay, but I mean, anyway, I need to cover other numbers also. So if you can complete your 3+ years of experience, your package can go up to 15 to 20 lakh per annum, and with 5+ years of experience, it will be around 25 to 30 lakh, and with 10+, it will be around 60 to 80 lakh per annum. Okay, but these are not fixed numbers, by the way. So these are you can consider industry's average number. Your number could be plus or minus some percentage based on your personal performance and based on the company where you are working. But most of the people join as a fresher only, right? You can focus on the very first number, 4 to 6 lakh per annum as a fresher package, what we are promising from our side. But we have many students who crossed that mark and got much higher packages. So as I mentioned, we have a collaboration with close to 200+ companies, which includes most of the MNC companies who have a presence in India, some service-based companies and few startups as well. So whenever they have a requirement in analog layout domain, okay, so from our side, from Takshila Institute side, we are going to arrange an interview for you. Okay, once you successfully complete your course and pass all the eligibility criteria for the interview, so we are going to what schedule an interview with these companies, and a minimum package what we are promising from our side is 4 to 6 lakh per annum. So very important point to note from this slide is your tool support and your interview support will be with you till you get the placement. We are not going to remove your tool access immediately after completion of your course, because obviously for a few students or even many students, it may take some time to get the job immediate. It may not be possible to get immediately. Maybe, I mean, if you are lucky enough, you can definitely get immediately. But let's say if you are not able to clear very first interview or second interview, definitely you need a tool access to practice and answer with confidence for the next upcoming interview. Okay, so for that reason, we are retaining the tool access till you get the placement. Okay, so after you getting the placement only, we will deactivate your tool access after getting the confirmation from you. Okay, so definitely your tool and interview support will be with you till you get the placement. Okay, you can note down this point. So here are the companies where our students are already working. So you can notice all big MNC companies who are in VLSI industry, and already our students are working over there. Okay, and if you complete your course successfully and pass your eligible criteria, then there are very high chances that you are going to work for one of these companies. Here is our 2024 placement related details, and we have many students, as I mentioned, right, who crossed that barrier and got multi X number what I'm when compared to what I'm quoting before, like that 4 to 6 lakh per annum. We have one student, she got 20 lakh per annum as a fresher package itself, and she got placement in On Semiconductors, which is a product based MNC company. And another student, she got a Synopsys with a very good amount of package, and even another student, she got 12 lakh per annum as a fresher package in Micron Technology, which is again a product-based MNC company. Okay, so all these are product-based MNC companies in VLSI industry. Okay, and we have a few placements in service-based and even for startup also. So definitely, if you are like successfully complete your course and pass your eligibility criteria, so definitely I can see your photo in my next year's presentation. So not just only those 3 students, we have a multiple students who got the placements in different companies. So I'm proudly saying we have a close to 100% placements for all our batches who enrolled for the course and completed them successfully. They got the placements in different companies. So I have a multiple slides for this year itself, and you can see all over here. So with this, I'm done with my non-technical stuff and I'm going to talk about course curriculum. So before going to that, if you have any questions related to the topics, what we discussed till now, you may ask now. I'll wait a couple of minutes over here if you have any questions. Any questions? Rohit? Okay, no doubt, sir. Thank you, Rohit. Thanks for your... Okay, anybody else? Any questions? Okay, if no questions, I will ask few questions, okay? So how many of you know here CMOS fabrication steps or CMOS circuits? Don't worry, I don't ask any questions on that. Okay, I just need to know the count. How many of you actually know the CMOS process steps and CMOS circuits? If I give you an expression, you should be telling how to draw the CMOS circuit for it, okay? Rohit is saying he knows it. Good, one. How many are there? Only one? You can raise your hand, put the thumbs up symbol, or you can type in the chat, or you can unmute and say, yes, sir, I know. I just need a count. Only one person? Okay, fine, no issues. So this is expected, but not at least one person. Generally, we'll have at least 25 to 30% of the total number of students. They know this topic because this has already been covered in your BE Tech for many universities. Okay, but what we observed is from the academics, this topic is missing. Okay, but this is very important for a VLSI engineer. Okay, doesn't matter which subdomain you belong to within VLSI. You may choose PD, you may choose schematic design, RTL, functional verification, or even DFT. Okay, but knowledge on CMOS is mandatory and it is very important. So after observing this from the academics, right, what we thought is we thought of covering this topic in detailed way in this course. So that's why we are keeping that in the module number 2. Sachin is saying, I know the fab steps. Good. Yeah, that's what I'm looking for. Along with that, how to draw a CMOS circuit. Let's say if I ask you, draw a CMOS circuit for NAND gate, draw a CMOS circuit for NOR gate, something like that. Okay. But anyway, we are going to cover that. But I just wanted to know the count, how many of you actually know that particular topic. Okay. But if you don't know also, no need to worry about it. We are going to cover in a detailed way because as I mentioned, right, this is very important and you cannot skip the topic for sure. If you wanted to work in VLSI domain, doesn't matter which subdomain you wanted to, but that topic is very important. Okay, and the second question, how many of you actually know what is analog layout design? So what exactly we are going to do? Any idea? Because this is going to be your career and today you are planning to choose your career, right? So what exactly we are going to do as an analog layout designer? Any idea? I really appreciate if you unmute and answer this question. Anyone? Routing and floor plan, Rohit is saying it is crisp, but need more explanation, Rohit. Why we need to do routing and floor plan? What is the purpose of it? Why we should do that? No one? Okay, so I will take a non-VLSI example and I will try to answer this correlating to that non-VLSI example. Okay, let's say I wanted to construct a building. Okay, but assume that I don't have any knowledge on anything about that building. I just have a basic idea. Okay, this many floors I need and this many bedrooms, this many bathrooms, this should be my garage, parking area, all those things. I know the top level information. Okay, Sachin is saying bringing schematic to layout. That's correct, Sachin, but why we should do that? Schematic to layout, it is absolutely correct, but why we should do that? What is the importance of layout? Okay, so let me answer that. Okay, so I don't want to waste the time, but yeah, again, very good try, Rohit and Sachin. I really appreciate your efforts. To minimize the area, power and delay, that is correct partially, but that is not the only reason why we do the layout. Okay, let me tell you that. Okay, no need to worry about it. Okay, so let's say I wanted to construct a building, but assume that I don't have any knowledge. Okay, what material I should use and how much I should purchase and what should be the quantity and where should I buy. Nothing is there. Okay, I don't know anything. Only thing what I have is the enough land to construct and enough money to do that. Okay, what should I do? Can somebody tell me? What should I do if I wanted to construct a building or let's say a house? Okay, I just know the basic information. What should I do? This is a generic question, right? Everybody sees in their regular day-to-day. Sindhu is saying proper plan. Exactly, Sindhu. That's correct. So I don't have any idea on that. Then I am not the right person to do that, right? So what I do, I generally approach, not me, even anybody, generally approach a architect or a civil engineer, okay, in layman's language. So I approach a civil engineer, I will say, okay, man, this is my budget, let's say 1 crore, 2 crore, whatever, and this is my land area, and these are my requirements. Okay, based on my requirements, based on my budget, what he does, he create a, okay, Shashi Kumar, Satish Kumar is saying strong basement. I don't have any knowledge on what is a, I don't know even the definition of strong basement also. Okay, that's what I said. I don't have any knowledge. So that's why I'm approaching a civil engineer or architect, whatever you call it. Okay, and I will tell him the top level specifications. Okay, these are the things I wanted to do. Okay, and whatever he charges, I will pay that amount. And what he does, he create a blueprint or a plan for my building, right, with proper dimensions. Okay, this many feet or meters width, this many feet or meters length, height, with all proper dimensions and designs, everything, by considering my top level inputs. So he design a blueprint or a plan for my building. Okay, without that, why we need a plan? Because this is a like a costly work, and if you don't have a proper planning, obviously there are very high chances that you may commit a mistake. May not be you, maybe even a construction company who has a very good knowledge on construction field also may commit a mistake if they don't have a proper planning. So that's why doesn't matter what type of civil work it is, first they plan it properly with the proper measurements, dimensions, everything mentioned on that plan. Maybe they will use a paper or they use a CAD tool, something different. Okay, and after getting that floor plan or like the blueprint of my house, what should I do? Even I don't have any knowledge on material science, so I approach a construction company who can construct a building based on my plan. Okay, I will hand over that plan to them and they will construct the building for me. Okay, they will quote, okay, this many lakhs or crores of amount is required to construct this. They will quote a money, so I'll give that money to them and they will construct a building for me and they will hand over it to me. Okay, something similar in VLSI also. Let's say you wanted to build a silicon chip. Assume you are building a audio application. In that audio application, you need a, what is the important chip in audio application? Any guess? I am designing a home theater system. Assume that. Okay, what is the important chip in that home theater system? Any idea? Amplifier. Correct. Sachin, good guess. Yeah, correct. So I need an amplifier chip. as I mentioned, I don't have any knowledge on VLSI. So what I do, I go to a VLSI company. Let's say, take an example. Okay, Intel. Okay, assume Intel. Okay, I go to Intel and I will talk to them. Okay, I need an amplifier. Okay, what are the top level specifications for amplifier? Input impedance, output impedance, voltage, gain, PSRR. There are some top level specifications. Area, how many pins you need, all those top level information. I give it to them. In that Intel, okay, what they do, they create a blueprint for my chip. Okay, so as a VLSI engineer, doesn't matter which subdomain you belong to, you are going to involve in creating the blueprint of that particular chip. Okay, so in again within VLSI we have front end, back end, because a single person cannot design a complete chip, so it was divided. Okay, so whenever you are creating a blueprint as an analog layout engineer, what you are going to do once you complete the course and join in any of the company, you are going to design a layout, okay, for that particular chip for all the analog modules. Every chip file will have both analog and digital. Okay, so we don't have any specific chip which has only analog or only digital. Nowadays everything is mixed signal. We will have analog blocks, we will have digital blocks. So if it is an analog block, as an analog layout engineer, you are going to work on it. If it is a digital block, there is another similar domain called PD or physical design. Okay, they also do the layout only, but they do for digital circuit, and you are going to do for analog layout, analog blocks. Okay, why we need the analog layout? Okay, so if you wanted to fabricate, right, so you need layer by layer information. The similar example, right, the civil engineering example, if you wanted to construct a building, you need a plan for proper, okay, what should be your basement height, first floor height, second floor height, like that. You need a layer based information, right? For each layer, what is the dimension, or each stage of your building, what is the dimension, width, length, height, like that. Even if you are talking about a very big house where you can visually see all the things, you are taking too much of care. But when it comes to the silicon chip, right, even it is very very small, right, it will be in the order of micrometers or nanometers in range. So definitely this needs a lot of attention to put all the dimensions properly. Okay, so as an analog layout engineer, you are the person going to put those dimensions. Okay, what is your poly width, poly length, diffusion width, diffusion length, P implant, N implant, metals, vias, contacts. There are so many layers which were stacked vertically, one on top of other. Okay, so as an analog layout, you are the responsible to design that. Okay, so you can assume yourself, or you can imagine yourself as a civil engineer or an architect, but not in civil engineering, in VLSI chip designing. Okay, so you are the person going to decide all the physical parameters, what should be your chip width, chip length, how many pins it should have, and which circuit should sit where. Okay, somebody told the floor planning, right? Yeah, that comes under floor planning. Okay, so in a single chip you will have multiple small circuits. You will have, let's take amplifier, you will have a first stage, second stage, then final impedance matching stage, then power amplifier, like a power module block. So many different small circuitry will be there. You are the person going to decide which circuit should sit where. Okay, what is the optimal location or optimal place for that particular circuit? Okay, you are the person going to decide that. Okay, so this is a top level, a brief overview of what exactly you are going to do. But trust me, this will be very very interesting and challenging as well. Okay, so definitely you need to apply your knowledge and skill, then only you can come up with a good layout. Okay, so any questions around it? So around analog layout, any questions? Is it clear first of all? Pin drop silence.
Yeah.
Okay, good. I think at least a couple of people responded. So that's why I told you the non VLSI example, right? You can just assume yourself as an architect. Okay, generally they do building planning, right? So you are also going to do similar work in a CAD tool. That CAD tool is your Virtuoso, and you are going to do it for your circuit. Okay, that is used for fabrication of your layout, will be directly sent to the fabrication house or fab, where they will fabricate your layout based on your the layer information what you are given. Okay, so that's it. Let's go back to the presentation. Okay, so here we have totally 12 modules, 1 to 11 modules. It is purely technical, and I have a separate slide for each individual module, so I'm not reading them over here. Okay, I'll directly jump over there. So very first module, we are going to talk about all the basics, as I mentioned, right? So basics are very, very important for any VLSI domain, okay, not just analog layout. So we are going to cover all the basics. We start from analog basics like RC circuits, op amps, amplifiers, filters, feedback techniques, MOSFET related basics like their current equations and region of operations, what is the difference between BJT and MOSFET and how they are related, all those things related to the basic analog we are going to cover. And even when it comes to the digital also, combinational and sequential circuits, adders, subtractors, multiplexers, demultiplexers, code converters. So all the basic stuff what actually you learned in your first year and second year of graduation. Okay, but all these topics we will discuss in a brief way, not in a detailed manner. So I recommend you to go through these topics once again if you have a gap or if you are working in a different domain and now you are planning to switch your career to VLSI, right? So there are very high chances that you might already forgot all these topics, but these are very, very important. Okay, so try to go through these topics once again, but we are going to cover them in our classroom. Second module, as I mentioned, very, very important module, and you cannot skip this module. Okay, CMOS circuits and CMOS process related things. Okay, what is CMOS and how it is going to be fabricated, and what are the advantages and disadvantages with the CMOS, and how to draw a CMOS circuit for a given expression. What is stick diagram? What is layout diagram? How to converge or how to convert your schematic diagram or a circuit diagram to the stick diagram or layout diagram. So all basics we are going to cover, but this module, I think a few universities they are covering in their graduation. I think second year or third year, one of the subject VLSI. So they are covering it. So if you have that subject, you are fortunate. But if not, anyway, we are going to cover. So you will become fortunate. Okay. So third one, it is little different. Basics of Linux. So you may ask, sir, why Linux knowledge is required? Okay, right from the module number 4, we are actually going to start working on the tool. Okay, and the tool supports only Linux based operating system. It does not have any Windows or Mac equivalent available. So you have to learn Linux if you wanted to work with the tool. Okay, without having knowledge on the operating system where you are actually working on the tool, right? So this will be very, very difficult. Okay, so for that reason, we are covering basics of Linux over here. Unix or Linux, both are same, don't get confused. Okay, so here things will be mostly command based. Okay, and there are like hundreds of different commands available, but luckily you need not to learn each and every command. Okay, there are like 10 to 15 commands are mandatory to learn because you are going to use those commands in your day-to-day activities. Okay, so that's why we are covering it these over here. Now you may get a question, sir, I don't have a Linux laptop, what should I do? Or and I don't have a Mac laptop, or I have only Mac, or I have only Windows, what should I do? Okay, so whatever you have, that is sufficient. Okay, you need not to change anything in your operating system, laptop, or nothing. Okay, so this software, Cadence Virtuoso software, it supports only Linux based operating system, and it needs very high processing and memory requirements. It has high memory requirements and it needs high processing requirements also. So generally for your personal computers, you may not have that configuration. So what we do is we install the software in our server and we will provide you access to that. Okay, so you can connect to the Institute Linux server from any laptop. It can be a Windows, Mac, or even a Linux laptop also. You can connect. Okay, so in the day one itself, we are going to discuss all those topics. Okay, what is VPN and how to connect to the Institute server, how to open it, that part we are going to cover. So fourth module, as I mentioned, right, we are going to start working on the tool. So here you will see a lot of different names over here. Again, don't get confused. So I will try to address you one by one. So the main tool which we are going to focus or teach you is Cadence Virtuoso, which is the primary purpose of this tool is to draw or create a layout. Okay, after creating your layout, somebody should check, right, whether everything is correct or not. Let's say if you write a program, what we do, we compile it for some errors, right? Maybe syntax errors, runtime errors, there are blah blah things are there. Okay, I'm not knowledge in that, but again, so you need to compile your code to check the errors, right? So here also conceptually they are same. So we will have physical verification checks, or PV in short. You can note down that name if you are interested. By the way, from now onwards, I'm going to talk, or I'm going to tell you a lot of keywords or a lot of abbreviations. Definitely, you may not be knowing all these things because all these terminologies are industries related. Okay, but if you are really interested, you can take the running notes. If not, just listen and leave it for now. Once you join the course, we are going to discuss in a detailed way. Okay, for now, you just listen and leave it. So as I mentioned, right, PV checks, which checks the quality of your layout. Okay, how efficient it was done. Okay, based on different parameters and different requirements. Okay, so here we have three primary checks actually. One is DRC, design rule check. Second one is LVS, layout versus schematic, and the third one is ERC, electrical rule check. If you wanted to say, let's say I gave you an assignment, create a NAND gate for this schematic. Okay, if you just simply create the layout, that is not the end of your assignment. Okay, you need to run all these three verification checks, PV checks, DRC, LVS, and ERC, and fix if you have any errors or violations in that particular check. If you don't have, then you can consider yes, your assignment is completed. Okay, but simply not just doing a layout the way you want is not the end of your assignment. Okay, remember that you need to finish or complete these three checks, and if it has any violations, you need to fix and rerun it. Okay, you can assume this something like your code compilation. Okay, whenever you are trying to run a code, right, if you get some errors, you will fix it and rerun, right? Something similar here also. Okay, but to run these three checks, definitely you need a software. You cannot do it manually. So that software here is Calibre or Assura. Both names are mentioned. The purpose of these two tools are same. Okay, they are going to run physical verification checks, but they are from two different companies. Calibre is from Siemens, and Assura is from Cadence. Okay, so we are going to use Assura tool for your physical verification checks for your LVS, DRC, and ERC. Okay, so let me take you to the virtual machine and show you how exactly your virtual machine looks like and how your tool looks like. Let me show you that. Give me a minute. I will quickly present my virtual machine. So once you enroll for the course, you will get a dedicated Linux virtual machine through which you can access your tool anytime. Okay, so let me know once you are able to see my screen. So hope it is visible. Is it visible to everyone? Linux desktop? Okay, Sachin is saying yes, sir. Okay, good. Thank you. So this is your Linux desktop. So here you just need to right click and open terminal. As I mentioned, right, everything will be command based over here. So I have already opened, so I just directly go there. Okay, so here you need to execute few commands to open your tool. First, you need to navigate to your work area. So CD, change directory to my work area. And after this, there are few steps actually you need to run before opening the tool. So what I did, I put all those commands in my bash RC file and I just sourced it so that in a single step, I can complete all those settings, whatever it is required. And then I use the command called Virtuoso. Okay, so this opens me a tool or a primary window. So this is the primary window, and we call it CIW, command interpreter window. Okay, again, all these are keywords. If you are not understanding, don't worry, just listen and leave it for now. Okay, so you can notice here Virtuoso is the tool name and this is the version number, and this is some log file you can ignore for now, later we can discuss. And this is the company name, Cadence Design Systems is the company which is providing this particular tool. Okay, and after this, the second important window what I wanted to talk today is this one. This is schematic window. Okay, can somebody recognize this circuit? What is this? Which circuit it is? Any idea? By seeing, Is it clearly visible to everyone? What is this circuit? No idea. Yes, you can notice name also over here in your title bar, right? ADC Cascode Op Amp. It is a part of ADC. So Cascode Op Amp is the circuit name for this. You have a differential amp or op amp. Okay, the first stage and the second stage, we have output stage like this. And by the way, this is going to be your first assignment in analog section. We have both analog and digital sections. For analog section, this is the first assignment you are going to get. Okay, so as a layout engineer, you are not going to work on creating this circuit. Okay, so there will be another person in your team called a schematic designer or a circuit designer, whatever you call it. They create this circuit for you. Okay, front end and back end, two are there, I told you, right? So as a part of front end, they create this circuit and they give this schematic details to us as a backend person. Okay, so we are going to take that and we need to create a layout, something like this. So this is the layout. Okay, I told you, right, physical dimensions. So if I fabricate this circuit exactly, I will get 55 micrometer width and approximately 50 micrometer height. Okay, so all these units are in micrometer, by the way. Okay, so this is how you can define physically all the dimensions. Okay, you are the person going to decide what should be your chip size and which circuit to be placed where and how they should be connected within the chip. Okay, you have a complete control on it. Okay, so if you know CMOS fabrication steps, right, you can relate my explanation to that. Okay, so whenever they are fabricating a silicon, first what they do for a CMOS process, they take a P substrate. The black color background, whatever you are seeing, right, that you can consider as a P substrate. After P substrate, the very first layer they are going to fabricate is N-well. So wherever you put this pink color shapes, right, they fabricate N-well over there. And similarly, thick oxide, gate oxide. Okay, there will be an oxide layer between your channel and the gate, right? So wherever you put this red color shape, they fabricate a oxide layer over there, which will form a the insulating material or a dielectric material between your gate and your channel. Okay, and then poly, which forms a gate for you, P implant and N implant for your source and drain terminals, and then another thing you can notice over here from the schematic, right? So there are wires which are connected among the terminals of the different MOSFETs, right? So after placing the MOSFETs, if you wanted to connect them, you use metal 1, metal 2, metal 3, like that. There will be like n number of metals available. You can connect your terminals of the MOSFET with these metals. Okay, so how many terminals we have for a MOSFET? Anyone? How many terminals for a MOSFET? Not BJT, MOSFET. How many terminals? Basic question, even a diploma student can answer. 4, 3, 2 people, 3 people told 3, sorry, 4, and 1 person told 3, which is correct. I think obviously majority is correct. So 4, not 3. Okay, so we'll have 4 terminals: source, drain, gate. These 3 are the primary terminals, and everybody ignores the 4th terminal, which is bulk or body. Okay, so the 4th terminal has again 4 names, and this is a important interview question. Okay, so what are the 4 different names of the 4th terminal? You can call it body, bulk, substrate, and some people call as a back gate. Okay, you can name with any of these 4. Okay, but all 4 represents the 4th terminal, the body terminal or the substrate terminal. Okay, so if you see my window, right, so the one box, the highlighted white color highlighted one, you can consider that as a one MOSFET. Okay, so primary 3 terminals will have over here. Okay, the right side white color dots are not dots, small squares, I should say, not dots. You can consider them as a source terminal. Okay, come on. Okay, this one. And the left side one is source terminal, and right side one is a drain terminal, And the bottom you have over here on the poly layer, right? So what is this terminal? On poly we'll have gate terminal. Okay, so these three are the primary terminals. Okay, if you see the schematic, every MOSFET has a 4 different terminals, these 4 dots. Okay, source, gate, drain, and bulk was represented in the center, right? But when you go to the layout, generally what we do to save the area, we don't put the bulk connection for each individual MOSFET. Okay, what we generally do is we group the similar kind of MOSFETs as an array, and we will put one body connection or a bulk connection for it. So the white color rectangular shape you are able to see, right? That is the bulk connection or body connection for all the MOSFETs what you are seeing inside. The green color one rectangle, you can consider one MOSFET here. So you can count how many MOSFETs are there. So for all of them, we have a similar connection, similar connectivity. So to save the some area, what we do, we group them as an array. Okay, we make them as an array and we put one around one bulk connection or one substrate connection for it. Okay, so this how your layout looks like. Okay, so definitely once you start learning about it, you will feel much interesting about it. And another thing, this is the window where you are going to spend most of your work time, and it has a lot of menus, lot of sub menus, and it has like literally hundreds of different options. And as a layout engineer, you should know each and every option. Okay, if you master the tool, you can complete your work or a task given in a very short time. For every single command, if you are looking for all the menus, right, so definitely it will take a lot of time for you, because you need to do the similar kind of step recursively, right? So definitely you need to explore all the options whatever it is available. But very very important options, everything we are going to cover in the classroom, but definitely these hundreds of options may not be able to cover in the class. So some will be given as assignment and a self exploration, we are going to give some of them. Okay, so this is how your layout looks. Any questions about the tool, about the work, about the layers what we discussed till now? Any questions? Do you feel it is interesting? Okay, good. Yeah, but definitely once you start learning about it, right, you definitely feel it will be very very interesting. Okay, so you don't get bored for sure, because every day you will get a new challenge. This is not going to be same work what we do. So every day new challenges, new blocks, new circuits, a lot of challenges will be there. It is not going to be an easy task for sure. Okay, I think we have only 7 more minutes. I wanted to ramp up fastly. Let me go back to the presentation. By the way, if you have any questions, I'm ready to take, I can extend myself a few more minutes after the 7 o'clock also. So I'm ready to take the questions if you have any. So after fourth terminal, the demo, right? So from fifth terminal on, fifth module onwards, right? So we start learning about some of the theoretical concepts. Why you should learn any task, anything, you cannot do it blindly. Okay, there should be certain rules and regulations, guidelines, best practices, what not. Okay, so too many things will be there. So first of all, we are going to provide a theoretical knowledge on them. Okay, let's say take a latch up concept. What is latch up and why it occurs in a CMOS circuit, and what happens if you don't consider latch up when you are working on a layout? What are the potential impact on your chip? Okay, like that, each and every topic over here we call it DFM, design for manufacturability. And here 4 major concepts we are going to discuss. One is latch up, antenna effect, electromigration, IR drop, and self heat. So these are very very important modules or important topics for analog layout engineer. Okay, so most of the interviews, right, definitely questions on all these topics can be expected. Okay, you can assume imagine how important they are. Sixth module also something similar, deep submicron process challenges. In that again we are going to talk about STI, shallow trench isolation, well proximity effect, length of diffusion effect, metal density, and ESD, electrostatic discharge. Okay, so again, these are also very, very important, and you need to learn them theoretically and apply your theoretical knowledge when you are actually working on blocks where you can apply these topics. Okay, so you cannot apply everywhere ESD related things because it is like your circuit dependent, right? So you need to understand where I should implement ESD related guidelines, where I should implement latch up related guidelines, where I should implement antenna related guidelines. Okay, that comes only by learning all these topics theoretically. Seventh module, we have two substreams. One stream we discuss about shielding. Okay, what is shielding? What is a critical signal or a sensitive signal, and why it is a noisy signal, and how to isolate a sensitive signal from a noisy signal? What is crosstalk, and how to do shielding like sidewall shielding, coaxial shielding? How to do that? That part we are going to take in a theoretical stream, and in practical one, we are going to start working on the layouts like your NAND gate, NOR gate, inverter with a different drive strength. We are going to work on that. All the layouts, hands-on experience you will get on the tool. So eighth module, it's analog layout related, and here you are going to get the assignments related to the analog layout, both eighth and ninth modules, and close to 40% of the total number of classes we are going to spend on only these two modules. Okay, and module 8 and module 9. So they are very, very important for analog. So here we talk about matching, what is mismatch, what is common centroid, interregistration, guard ring, seal ring, constraint and module based full chip level floor planning. So all these techniques we are going to discuss in the module number 8. Module number 9, mostly assignment execution based on what you learned in previous modules. Okay, like your cascode op amp, flash ADC, band cap reference circuit, and LDO, low dropout regulator. So all these are decent sized functional blocks, and you should have knowledge on all these blocks. So you are going to work on layout for them. And again, there is a keyword already mentioned, right? Layout design and physical verification. Okay, you need to do your physical verification like your DRC, LBS, and ERC. All these three checks also should pass. Then only you can say your layout is done or your assignment is done. Okay, 10th module, little different memory layout related concepts. So memory layout, you can consider subdomain within analog layout design itself, because the tool, the way you do the layout, everything will be same. The difference is the type of circuits actually you are going to work on in memory layout. Okay, here majorly 6 transistor bit cells, row column decoder, sense amplifier, pre-charge circuits. So these are the blocks you will get in memory related layouts. Okay, and along with the layout, we are going to discuss about DRAM basics as well in this 11th module. Sorry, 10th module. 11th module, again, very, very important module, advanced module. And here we have again two substreams. In one substream, we are going to talk about SOI process. Okay, so in module number 2, whatever fabrication steps we learned, that is related to bulk process. Okay, bulk, we call it bulk process. But in the industry, there is another fabrication technology or fabrication process is there, that is called SOI, silicon on insulator. Some people call it FDSOI, fully depleted silicon on insulator. Okay, so this is a little different process technology compared to the regular bulk process what you learn in your graduation. Okay, few companies, especially few MNC companies, they are actually working on SOI process because it has its own advantages. Okay, so that's why they are working on these technologies. So definitely knowledge on SOI process is mandatory, I would say. And second substream in module number 11 is FinFET, which is an advanced MOSFET structure. Okay, and how exactly your FinFET looks like, and what are the additional challenges as a layout engineer you will get related to FinFET layouts. That part we are going to cover here in the module number 11. Module number 12, it's like a mixed module, hybrid module, I would say, because it has both technical and non-technical things. So here, first thing, we are going to conduct a course completion test to assess your knowledge. Okay, how much you are confident for all the topics, whatever it's been discussed till module number 11. And we are going to conduct a mock interviews as well. And if somebody needs help in preparing their resume, that also will be considered over here. And finally, few personality development programs we are going to conduct. Okay, so this is the 360-degree view of the course, and trust me, we have all the topics, whatever it is required for analog layout designer. Okay, so with this, I'm done with my presentation and open for questions. So this is the last chance and the right time to ask your questions if you have any, because this is the point where you are choosing your career. So you should have a proper knowledge or enough knowledge to do that. Any questions so far? Not so far. We are already done. Yeah. Sir, what are skills industry expect for layout design engineer? Good question, Rohit. So whatever we are discussing here, those are the expectations. So because as I mentioned, right, ours is purely industry standard syllabus. What industry is expecting from the freshly graduated person with training experience, whatever they are expecting, everything is already included over here. Okay, so if you have a basic knowledge on electronics and electrical things, that is the primary prerequisite I would say for this course, and you can join the course, and whatever it is required, skills, everything, okay, we are going to cover here. So if you focus on this course, definitely you can meet the expectations of any company. Only thing is, whatever efforts we are putting, we expect a similar efforts from your side also. Focus on the course and learn the topics, whatever it's been discussed in the class. Hope it answered your question, Rohit. How will be our work as a layout design engineer? Kindly explain it. Okay, good question. So as I mentioned, if you go to any company, okay, there will be front end and back end within analog domain itself, analog VLSI itself. Front end people, they create a schematic or a circuit. I showed you during my tool demo, right? So they create a circuit, okay, and they do all the necessary spice level simulations on it. But that circuit is not sufficient for fabrication because it does not have any physical information, right? Physical dimensions, right? So without physical dimensions, you cannot fabricate anything. Okay, just assume our civil engineering example. Without having a physical dimensions, proper plan, you cannot fabricate. So what they do, they provide that circuit or a schematic to a layout engineer, and you need to create a layout for it, and you need to pass all the verification checks, whatever they mention in that particular project. And once you are done with everything, we are going to send this layout database to the foundry or a fabrication house. They fabricate based on our layout, and they will send the silicon chip back to us. Okay, this is how it works. And definitely layout work, I personally feel it is, maybe your opinion could be different, but it will be very interesting, challenging, and you should learn every day, not just in our institute, even after joining the course also, because every year we are getting new technologies, and MOSFET is getting shrinked and getting new technologies and new way of connecting the devices. Okay, so definitely you need to focus every day and learn every day. Okay, and definitely it's a challenging job, I would say. Okay, hope it answered your question. And Satish is saying, I'm 2019 passed out, working professional, I'm plan to switch career. Yes, so no need to worry about your, I mean, you are already working somewhere, right? Maybe academics or maybe software. So you are absolutely eligible and you can switch your career now and nobody will ask you. But most of the cases, as your prior experience is not relevant experience, that may not be considered. Okay, so that's what I wanted to tell you. I think Satish asked this question. Yeah, Satish Kumar. Yeah. And Balram is asking, I have a career gap. I mean, I have completed my MTech in 2012. I am working as assistant professor. What? You're absolutely eligible, Balram. I think it will not create any problem for you. Okay, but your prior experience may not be considered. You will be treated as a fresher only. But some companies, if you teach your in your academics or in your college or university relevant subjects, right? So definitely if you have knowledge on them, they may consider and they may give you a one level up job. Okay, it may not be like 10 years of experience, they may not consider for sure, but if you are knowledgeable enough, there are high chances that, let's say, entry level engineer, instead of entry level engineer they give engineer 2, something like that. Okay, we have few cases like that. So but definitely getting a job as a fresher is not a problem for you. Okay, so if you need more information related to the placement, right, you can just cross check with HR also once. Okay, they are the right people for it. Any industry level projects covered? Good question, Sachin. Already I told you, right? All these are industry level projects, whatever we are Cascode op-amp, right? Because as a layout engineer, especially analog layout engineer, you are going to work for blocks like this. Okay, Cascode op-amp, Flash ADC, bandgap reference, LDO, and if time permits, we will cover PLL also, phase local loop. Okay, that is also we are going to cover, but that depends on the time. But all these are industry standard projects only. Okay. So by the way, so these are the addresses of our offices in both Bangalore and Hyderabad. So if you want, you can take the screenshot. I will stop over here for questions. Any last questions? I will take two more questions if anybody have. Should I learn front end or back end? Which is better? So Balram, it's purely based on your personal interest, I would say. Okay, and front end means I'm hoping that you are talking about circuit design. So circuit design needs extensive knowledge on MOSFET level design things. Okay, design related concepts. Okay, anyway, we offer in Takshila, we offer both circuit design and schematic design, sorry, layout design. You may attend the demo of circuit design as well, and then you can decide which one is a better suitable job for you. Okay, so talk to the HR, so they will arrange you or they will inform you when they have this circuit design related demo session. Okay, so after that you can decide which one you wanted, but we have both. About career growth in VLSI, no doubt we have a very good scope, and we have a lot of growth prospects, especially now in India. Semiconductor investments are increasing day by day, and many companies, they are planning to start their offices in within India. Even fabrication houses also we may expect soon, but definitely within India we have a lot of opportunities and a lot of growth scope. Okay, no need to worry about it. So yeah, any other questions? If not, I think we can stop this session here. Any questions? Okay, if no questions, I can stop recording.